So this is the given, and the problem is that we have to obtain the true shape of this surface ABCD. So in this case, surface ABC. Surface ABC in this case is an oblique surface. Oblique surface thereby means that you may draw whatever view, front view, top view, or even side view if need be. But this surface ABC will not appear as an edge in any of the standard views, front view, top view, or side view. So the direction of viewing front is also given in the problem. So looking in that direction, you can make the front view, and accordingly you can also make the top view. And you can see that this triangular shape ABC is appearing as one triangle A dash B dash C dash here in the front view, and it is appearing as triangle small ABC in the top view. So the idea is that we want to find the true shape of this triangle ABC, but we don't have the edge view of the triangle ABC. If we have the edge view of the triangle ABC, in case we have it, then we can simply get its true shape by putting a reference line parallel to the edge view of ABC, and then we can easily get the true shape. But in this case, the edge view itself is not available. So in this case, the trick is that you first have to obtain the edge view, right? Now, what do we mean by edge view? Edge view means that all the points that lie on the boundary of the surface, like in this case it is a triangle. In the previous cases we have done when assignment number 1 and 2, where the shape of the surface was rectangular. So there we had 4 points A, B, C, D. Now in this case it is a triangle, so we have only 3 points A, B, C. So the edge view means that all the points that lie on the surface, that is in this case point A, point B, point C, all the 3 points, they should lie on one single line. Like in this case there are 3 points, but these 3 points are lying on 3 different lines, like in this case. Similarly, in this case the 3 points are lying on different lines, right? So edge view is the one in which all the 3 A, B, C will lie on single line, right? Now how can we do that? So we can just bring down these important points. Let us bring it one by one. So the first step, as we discussed yesterday also in the second assignment and first assignment, that whenever you are interested in finding the true shape of any surface, so you have to first identify the view, that is front view or top view or side view, where the surface, in this case surface is ABC, has an edge view. In this case, step number 1 is not possible because none of the two views, that is front or top, none of the two views has surface ABC appearing as a line, right? So in this case, what is the alternate with us? The alternate available to us is that if the edge view is not there, then we have to convert any one side of triangle ABC to a point, right? Now this is quite logical, that if I've got 3 points and the 3 points are not lying on a straight line, right? If I've got 3 points, one is here, another is here, another is here. So it means, say if this is point A, this is point B, this is point C, and all the 3 points are not lying on one single line, what can I do is I can simply make the point view of any one line. Now let us say if I convert BC into a point, then it means point A continues to be here, and point B and C, these 2 points will merge at one location. So eventually you will have point A, point B, as well as point C on the same line. So that is what becomes the edge view of the surface, and we can easily find out the true shape of the surface. So in this case, if the edge view of the surface is not available, then we will first have to find the point view of a line, right? Now if I have to find out the point view of the line, how do I get the point view of the line? So there is a precondition that should be satisfied if you are interested in finding the point view of any line. Let us say in this case there are 3 options. I can find the point view of AB, or point of view of BC, or point view of AC. That is my choice, right? But there is a precondition for finding the point view of any one of these lines. Now, what is that precondition? That precondition is mentioned here. Let me bring it down. So that's the precondition. So precondition is, this step 3 says the same thing that we have already discussed. Whenever any one side of the surface is converted to a point, whenever any one side of a surface in this case is triangle ABC. So if I convert any one side of triangle ABC to a point, surface that is triangle ABC itself will get converted to an edge. That is what we desire. Now the precondition for doing for getting the point view is mentioned here. So that is the precondition. So the precondition is that if I want to obtain point view of any line, any side or any edge, then I must have the true length of that particular side or edge or line with me, right? Now in this case, you first have to see that out of the 3 sides AB, BC or AC, which side has got its true length already available. If it is not there, if the true length of the line is not available, then we first have to find the true length also. Now in this case, let us consider one by one. If I consider side if I consider, let us say, side AB, right? Now, in this case, side AB, the front view of AB is A dash B dash. Okay, this is the front view of side AB, A dash B dash, and this is the top view of the side AB. So I can just mark it. This is the top view of the side AB, right? So this one is the top view of side AB, right? Now, if I just look at the front and top of line AB or edge AB, so one view, that is AB, is parallel to the XY line. So it means this is the true length of AB. This is the true length, right? Because if any one projection of a line is parallel to XY, like in this case, AB is parallel to XY, it means the other projection is the true length of that side, right? So I have A dash B dash as true length of AB in this case, right? Similarly, I can consider other edges also. So if I look at, let us say BC, if I look at side BC, the two projections of side BC, right? So that is front view of BC is somewhere here. If I just mark it in let us say magenta color, so that is the front view of BC, right? So this is the front view of BC, that is B dash C dash, and this is the top view of BC, right? Now again in this case, B dash C dash is parallel to XY, so it means this BC in top view is actually the true length of BC, right? So in this problem, you are already given the true lengths of the two sides. You are also given the true length of AB in the front view as A dash B dash. You are also given the true length of side BC in the top view, right? If you want to consider the third one also, we just need any one. But just for the sake of discussion, if you look at AC also, AC, the front view of the AC is a vertical line. The top view of AC is also a vertical line. So it means none of the two, AC or A dash C dash, none of these two views of line AC are parallel to XY. So it means we don't have the true length of AC given in this case, right? If you're interested, we can find it, but it's not given directly. So in this case, I have a freedom that I have the true length of AB given as A dash B dash, or I also have the true length of BC given as BC in the top view. Now you can choose any one of these two, whatever you like. I just need any one side. I just need to convert any one side to a point, right? Let us say, depending on the space availability with you on the sheet, you can proceed either in this direction or in this direction. Now in my case, let us say I'm assuming that I'm interested in finding I'm going to find the point view of BC, right? So I'm going to find the point view of BC, right? Now, to find the point of view of the BC, I must have the true length of BC, right? So that is given to me. That is already given in the problem. So true length of BC in this case is given to be small bc. That is given in the top view, right? So what I'll do to find the point of view of BC is that I just need to draw a reference line parallel to true length of BC, right? So in this case, I'm sorry, let me just repeat it again. In this case, you have to draw a reference line, not parallel, rather normal. I'm sorry, this has to be normal, right? So to find the point of view of BC, I must have its true length that is available. The next step is that I will draw a reference line, say x1, y1, that should be normal to this true length, right? And just for the sake of completion, let me also write the name of the first line, the reference line, that is xy. So this is my x, and this one is y. Okay, so this is my first reference line. Now I'm going to add second reference line. Now the second reference line has to be drawn in such a way that it is normal to this reference line, right? Now to do that, what we can do in AutoCAD is, if you're doing it manually, you can easily set your drafter. One scale of the drafter can be aligned with this true length. The other side will automatically be normal to it, right? And you can draw a line here, right? But in case of AutoCAD, what I can do is I can simply draw a line. This is just one option. I can simply draw a line and randomly draw it from any place, but make sure that it is falling 90° to this line. Shift right click and make it perpendicular here, right? So this line is now normal to the true length, but it needs to be shifted. Then move it and put it somewhere here, right? Make sure that this line does not intersect with the existing views. So this line should be well away from the top view. Now the reference line in this case is named as x1, right? x1, and the reference the other end is, this is y1, right? So this is the reference line x1, y1. Fine. Now what I have to do is I simply have to draw. Whenever you have a reference line, you always draw 90° projection lines on it, right? So I'm now going to go to the projection layer, and I'm going to draw a perpendicular line from B as well as C, because if I draw a line from B or C, it is going to fall 90° here, right? So this is my projection line, right? And this line is coming from B as well as C, because we have deliberately placed this line x1, y1 normal to BC. So whenever I draw this line starting from B falling normal to xy, that is also in line with the projection line coming from C and dropping 90° to xy, right? So this is one thing. Second, similarly, I draw another line from A and let it also fall 90° to this. Now you can use shift right click, perpendicular, and let it drop here, right? So this is the projection line falling 90° to x1, y1 and coming from A, right? Now we have to do the same thing that what we did yesterday. You can understand it in a way that I have to locate. Now this is my front view, basically. This is my front view, right? If we just mention, we all understand this is the front view of the object, right? This is front view. And the view on the other side is, this is top view, right? This is my top view. Okay, so I have got front view and top view. So the third view that is going to come from the other side of x1 y1 is going to be auxiliary front view. This is front view, this is top view. So the next step, the next view that we are going to get is auxiliary front view, right? So this is the view that we are going to now make is named as AFV, auxiliary front view. And how do we make it? That we all know. We have already done it in previous two problems. We have in one problem we have drawn auxiliary front view. In second problem we have drawn auxiliary top view. So in this case, just see what is the distance of point A dash from XY line. That is 10 in this case, right? Now the projection coming from A has to be extended by this much distance. So yesterday we used that command, lengthen command, but in this case you can use either lengthen command or you simply know it that this distance of A dash from XY line is 10. So you just need to extend this line, click at this end. You can also use lengthen command and just type in 10. So this 10 will make this projection line extend by this much amount. This increment is 10, right? And now since this is auxiliary front view, this is A dash, this is A. So this is the name of this point has to be A dash because it is a front view, so it has to have some dash on it. But just to differentiate it, I can add number 1 here. So this number 1 is subscript. So this point is actually A1 dash. So A dash and A1 dash both are 10 units away or 10 millimeters away from their respective reference lines. A dash का reference line है XY, वो अपनी reference line से 10 mm away है. A1 dash, which is auxiliary front view of A, that is also 10 mm away from its reference line, which is x1 y1 in this case, right? Now with the same logic you can extend the projection line from B and C. Now in this case, what is the distance of B dash and C dash from its reference line, that is xy? So in this case this distance is 100 for B and 100 for C also, right? So it means the projection line coming from B as well as C, which is common line, so I just need to extend it by a distance 100, right? So if I just measure this distance, so this distance from this location to this location is 100, right? So I have extended the projection line through a distance 100, and this point now is named as, this is C1 dash, this is C1 dash, comma B1 dash, right? So that is C1 dash, comma B1 dash, right? Where 1 can go as subscript. So actually this point here, this point that we have just obtained, this is point view of BC. Now edge BC is converted to a point, right? So if I say where is now triangle ABC? Triangle ABC is, if I just mark it with object line, triangle ABC has point A here, point B and C here. So it means this line actually represents triangle ABC, because triangle ABC has got 3 points ABC on it. Point A lies here, B and C, they are coincident at this location because this is the point view of edge BC. So this becomes, you can call this as, this line here actually represents this is the edge view of triangle ABC, right? I can just reduce the font. Okay, so this triangle here is actually edge view of triangle triangle ABC, right? So this line basically represents the edge view of triangle ABC, right? Now you simply have to find the true shape of triangle ABC. You have got its edge view with you. So to find its true shape, you just need to draw a line parallel to its edge view, right? So I can just copy this step here and paste it here for your understanding. So this is step number 5. So number 5 is to obtain true shape of a surface, draw a reference line parallel to its edge view, right? So in this case, the edge view of triangle ABC is available with us. So I just need to draw another reference line x2, y2 parallel to this, right? So one way of making line parallel to this edge view is that I can use the offset command. Offset through, let us say, certain distance, say 50, whatever, right? This can be whatever value you like depending upon the space available. So this is the offset line, and just you can increase its length marginally, say 30 on this side and 30 on this side, right? And then you can just name it also. This is now x2, this is x2, and this one is y2, right? So this is the reference line x2, y2, right? And now I just have to do the same thing. I will be dropping some projection lines from A1 dash, B1 dash, C1 dash perpendicular to this, right? And then you can just make this line, shift right click, make sure it is falling normal, right? So this line is 90° here and 90° here, and you can also keep the color same, the blue color, right? Now you have to extend these lines through certain distance, as we did here. We extended this line by 10 millimeters, we extended this line by 100 millimeters, right? Same way you have to extend this line as well as this line through certain distance. Now what is that distance, right? Now one logic you can keep in mind, please listen to it very carefully. See, right now I have got 3 reference lines drawn on the screen. This is very important. This you may not find anywhere written like this in any book, right? But you can just understand it this way, that okay, I'm just making the 3 lines with a different color for the ease of understanding. So this is green, okay, right? Now you can see there are 3 reference lines drawn on your screen. This is xy, x1, y1, and x2, y2. Fine, let it be red color. Now the important pattern to note in this case is that if I consider any 2 consecutive reference lines, consecutive means there is a sequence in which these reference lines are occurring. First comes xy, then comes x1, y1, then comes x2, y2. So if I take any 2 reference lines in in sequence, 2 consecutive reference lines in sequence. So let us say I consider xy as well as x1, y1, right? The distances of the points on outer side of these 2 reference lines is same. What does that mean? If I consider 2 reference lines, 2 consecutive reference lines, that is xy and x1, y1, points that lie on the outside means this zone is between these 2 lines, these 2 reference lines. So the top view in this case lies between this reference line and this reference line. So I'm not talking of this zone. I'm talking of that zone, or rather zones, which lie outside of these 2 reference lines. So for xy, the outer zone is this front view, everything, a dash, b dash, c dash. And for x1, y1, the outer zone is a1 dash, b1 dash, c1 dash, right? So the distances of the outer zones are same for 2 consecutive reference lines. Now if you apply the same logic to x1, y1 line and x2, y2 line, so it means the distances of B, A and C from x1, y1 has to be same as the distances of the projections that we are going to get here from x2, y2, right? So what I need to do is I need to extend this line further, because it is coming from A1. I need to extend it further by some distance. Let us say that distance is L. That distance L is actually this much, from here to here. It may be whatever, right? So in this case, it is 83.07, right? It will depend. Where did you draw this line normal? जब आपने x1 y1 बनाया था तो वो कहाँ पे बनाया था? It will depend upon that, because you just draw it at a place of your convenience, right? So it can be any value, right? But now the important thing is that this line that we are going to extend, it has to be extended by the same distance, whatever is this distance here. Now to do that, what I'll do is I'll go to lengthen command. Lengthen by right click, delta. What is the delta? I need to extend the line by this much distance, starting from this point, ending at this point at x1 y1, right? So that increment is recorded. And which line I want to extend? I want to extend this line, right? So this line is now extended. Now this point that we have located, this is coming from A1 dash, right? And this view, we have already said this is auxiliary front view. The new view that we are going to create here, this will be called as auxiliary top view. Rather, it is secondary auxiliary top view, right? So because the type of view that we always get across a reference line is always front view on one side, top view on the other side. For example, line XY has front on one side, top on another side. X1 Y1 reference line, it has top view on one side, auxiliary front view on the other side. Similarly, X2 Y2 will have auxiliary front view on this side and auxiliary top view on this side, right? So you will never have two consecutive views which are both front view types, or two consecutive views which are top view type, right? So it will always be alternate. So if this is auxiliary front view, this is auxiliary top view, right? So this is not front, so it means it is top, right? Now if it is top view, then how do I name it? I will name it as without dash. So I'll call this as A, because it is auxiliary top view, so it means there will be no dash. But how do I differentiate this point from the point that I have here in top view? So just to differentiate it, I will just write another suffix here, which is 2, right? And make it subscript, right? So this point is named as A2, right? And similarly, for point C and B, I need to make some extensions. Now, what is the extension for B? For B, it is going to be from this place to this place. I'm just doing it, I'm just marking these aligned dimensions for the sake of understanding. Otherwise, you can simply use the lengthen command, right? I'm just making these extensions just to make you understand. Okay, so lengthen delta. Delta is recorded from this place to this place, right? So that is the recorded delta, and I want to extend this line of B, right? So this point is now B2. This point is named as B2, right? So this is B2, and 2 can go in the subscript, okay? And so I have basically obtained this one length or one side of the lemon. Now I need to extend the same line for C also, but for C the distance is from this location to this location, right? It has to be extended by this location, right? That is 143 point something. But I have already extended it through this much distance to locate B. So what I can do in this case is that I can extend this line, just a second, I can extend this line further by how much? I can simply extend this line further by this much distance, which is given as distance of C from B, because B I have already located, right? So that in this case is 103, right? So how will I do that? Lengthen, right click, delta. The delta is recorded from this place to this place. So that is the gap between B and C. right? And I just extend it further. So that is an increment in the length of the line, and this is named as C2, right? So this becomes C2, and I can simply connect all these lines now, A with C and C with B, right? Now you can see, if I just fill the color, so this is the desired true shape of surface ABC, right? And these dimensions are just for the purpose of understanding. You can simply delete them, right? Okay, I'll just summarize it. I have got 4 minutes. So let me summarize. So in such problems, when the edge view of the surface is not given to you directly, then you first need to get the edge view. Now, to get the edge view of a surface, what we do is we reduce any one side of the given surface to a point. The funda is that if any one side of a surface, any one side of a surface appears as a point, then in the same view is also the edge view of that surface. कहने का मतलब ये है, अगर आप किसी एक surface के एक side को point में convert करते हो, तो वो पूरी की पूरी surface एक edge में convert हो जाती है उसी step में, right? So in this case you can see triangle ABC, we convert BC to a point. The moment we get BC as a point here, the complete triangle becomes a line here, right? You can try it with some rectangle also. You draw a rectangle front and top so that the edge view is not there. You convert any one side of that rectangle into a point, you will see the complete rectangle converts to a line. So this applies to any shape, right? So the funda is that if you convert any one side of a surface to a point, the complete surface appears as an edge. So that is what is required for making its true shape. So once you get the edge view of the surface, then it is very simple to get its true shape. That is by simply drawing a reference line parallel to the edge view and just transferring the appropriate distances. So you will get the true shape. Another important takeaway from today's discussion is that whenever you are dealing with such problems in auxiliary, then you always take care of the two consecutive lines. So whenever you consider any two consecutive lines, like the pair of consecutive lines is in this case either xy and x1y1, these are the two consecutive lines, or x1y1 and x2y2. So you, whatever may be the case, if you are dealing with a pair of consecutive reference lines, then the distances of all the points lying on the outer zones of both the consecutive reference lines, that is same. Like in this case, distance of a dash, distance of c dash, distance of b dash is same as distance of a1 dash, distance of b1 dash, distance of c1 dash from xy line, x1 y1 line. Similarly, if you consider the pair of x1 y1 and x2 y2, then the distances of a2, distance of b2, distance of c2 is same as distance of a, distance of c, distance of b from x1 y1, right? So consider the outer domains and make the distances equal, the problem is solved.